Hello, I am Mohammed Munir Raza. I am going to teach basics of chopper. Now, for chopper, just make sure that there are 4 to 5 marks is sure from this topic. So why you can't leave this topic in power electronics. The two most important topics are inverter and chopper for gate point of view. And in gate, there are only buck boost and buck boost are asked, and there is no need to remember any formula, and or if you remember formula, you may end up calculating wrong answer. So just know the concepts and just comfortable with the waveform and the basics of inductor and capacitor. For understanding chopper, you need to know some basic network theory. This time revising, you all know are knowing the average voltage across inductor is 0. The inductor don't allow sudden change in current. Why? Because VL is equals to L di by dt. If you are saying that it is changing the current in very short duration, that is dt tending to 0, L is equals to V by di by dt. Since di by dt is equals to 0, L needs to be infinite, which is impossible. Similarly, for the average current across a capacitor is 0, and the capacitor don't allow sudden change in voltage. The same reason that is I is equals to C dV by dt. Since dV by dt is tending to 0, C is equals to I by dV by dt, since it is going to be infinite, which is impossible. And the chopper converts constant DC to variable DC. Just it is nothing but chopper is nothing but it converts a constant DC to variable DC. How? Just by opening and closing of the turning on and turning off of the switch, you can get the output voltage for some time and for some time not, and if you calculate, then the average voltage will change. Now the chopper, it is also known as DC to DC converter. Chopper is named after its working to chop the constant DC voltage to convert into variable DC voltage. The basic difference in chopper and DC to DC converter is the presence of capacitor on the load side. That is, the ripple in the output voltage is minimized in DC to DC converter, that is buck boost and buck boost. Now the circuit diagram, in order to remember the circuit diagram, I have made just 3 words which will let you remember this configuration entire your life. And sometime in gate this confuse between the circuit diagram, so if you remember this, you will never be the prey of such mistakes. That is SDLC for buck boost, LSDC, buck boost, SLDC. Now I am explaining this, remember this, bear with me. Since in buck, S, then D, then L, then C. Just remember this. Near the source voltage, you have switch, then diode, then inductor and capacitor. Similarly for boost, L, S, D, C. Just to remember, it is nothing with the bookish thing. It is just to remember in order to be comfortable with the circuit diagram. Sometime in starting it, you may be messed with some things, questions like this. Then for buck boost, it is S, L, D, C. In buck boost, sometime in gate they asked a question which may let you just in, for example, in gate 2016 they have asked the maximum voltage across this switch, and they have given the magnitude of this voltage and this voltage, and the only concept which is needed to be answered that question is that the voltage across this is nothing but it is the negative of as shown. Why? Because when the capacitor is charged with this switch and the inductor is charged with this switch and it is discharged through here, the polarity of the capacitor will be positive on this side and negative on this side, and hence in that case V0 will be negative. That is the only concept which we want to ask if you know this or not, and many of the people have answered it wrong. And just to remember, SDLC, LSDC and SLDC. Now I am just explaining the buck converter. Now what to study? For chopper, you just know about the inductor current waveform, switch current waveform, diode current waveform, source current waveform, and the value of critical inductance and capacitance, and the current ripple and the voltage ripple. The maximum and the minimum current through the switches or other components are sometimes asked. Now let me explain the buck. Here I am assuming the continuous current mode, and I am assuming the purely resistive load. And don't worry, just resistive load are asked. And also you don't worry about any other, it is resistive load. So the average voltage across this load is V0, and the average current will be I0 is equals to V0 by R. Simple. Now this is the capacitor current, which is here you may say that it is acting as a filter. Here LC filter is they are acting as LC filter. I've explained this thing. And then the average voltage across inductor is 0, since we all are knowing the when the switch is on, let the switch is on, the voltage across this inductor would be nothing but Vs on this point and V0 on this point. So when the switch is on, the voltage across this inductor is Vs minus V0. So this is Vs minus V0, and when the switch is off, the inductor discharges through this, and the polarity across the inductor will reverse, and then the current will remain in the same direction. It will discharge through capacitor, charging the capacitor and giving the output voltage as V0, and here it will be minus V0. Now using the same concept, average voltage across inductor is 0, Vs minus V0 into dt. Duty cycle, the time for which the switch is on, is called duty cycle or duty time, and V0 into, this is called off duty. I'm sorry, this is off duty time. And the inductor current, since we know that VL equals to L di by dt, this basic equation, so you can use this for turning on or turning off, that doesn't matter, since when the switch will be turned off, it will V0. So VL equals to V0. When the switch is off, the voltage across an inductor will be V0. V0 equals to L into delta I by dt. That is the turn off time, 1 minus d into t. From here we can find delta I. This delta I is the peak to peak ripple of this output inductor waveform. And since the source current will be nothing when the switch is on, the source is connected. So the on time period of this waveform will be source current, and the off time of this inductor waveform, that means this waveform only, will be the diode current. Now the maximum current through inductor is the maximum current through switch and diode, since when you will see that this switch, inductor and these things are conducting in the on time period, and in the off time period these things are conducting. So the maximum current through the inductor and the switch will be same, and the diode will also be same. Now from you can see that Imax is equals to I0 plus delta I by 2. The maximum current, this thing, since the average load current is equal to the average inductor current, so the I0 will be the average of this inductor current. I0 plus delta I by 2 will be maximum current through the inductor, and the maximum current through the switch, and the maximum current through the diode. So, and similarly the I mean will be this point, minimum and maximum. This is the maximum. So you will get this. Applying now I will find this. Applying KCL at this point, IL is equals to I0 plus IC, and then IC is equals to IN minus I0. So if I subtract the I0 from this waveform, you will get this waveform, and this is the current waveform across this capacitor, that is IC. Now since we need to find the voltage ripple across the load, that is the same as the voltage ripple of the capacitor. So since we all know that Q is equals to CV and del V is equals to del Q by C, and del Q is nothing but the area of this part, that is this part is T by 2, this is delta I by 2, and this the area of triangle. So you will find delta Q is equals to 1 by 2 del I by 2 into T by 2, that is del I by 8F, and del Vc is equal to del Q by C. This is the voltage ripple. Now the inductor, the critical inductance, the value of critical inductance is sometime the minimum value of inductor for which the inductor current is just continuous. What does that mean? This means when this minimum current comes to here, that is the waveform will be look like this, something like this. That is minimum is tending to 0. So that is if you put the I mean equals to 0, that means in this equation I mean equals to 0, I naught equals to del I by 2, and I naught is nothing but V naught by R, and del I we have calculated, and just else you will find from this equation. Similarly, the capacitance, the value of minimum critical capacitance, the value of capacitance for which the output voltage is just continuous. That is this output voltage is just continuous if the voltage across the capacitor is just continuous. That is the value of critical capacitance. So for that, del Vc is equals to 0, minimum value, and since the average voltage across capacitor is equals to average voltage of the load, V0 minus del Vc by 2 is equals to 0, V0 is equals to del Vc by 2. Just remember this and you can find the critical value of capacitance just by putting the formula del Vc is equals to del I by 8 Fc, and then V0 is equals to del I by just 16 Fc. From this you may find, and you can find the value of delta I from the previous formula. Now let me conclude what we have taught today. The difference between chopper and DC to DC converter I have explained. I have introduced how to remember the circuit diagram of buck boost and buck boost circuit, and the theory of buck converter I have explained. Now after listening to this lecture, you can solve the question based on buck converter and revise the concepts, and just try to derive the formula I have just derived in the same manner. Solve previous 8 questions of ESC and GATE. Thank you.